So if you're talking about your own personal identity, talking about what you're known as. In different places, in different contexts, you might be known differently. You know, here at school, I'm Mrs. Pfeiffer, and when I see people at church that I also see at school, sometimes it's hard for them to switch and not call me Mrs. Pfeiffer, to call me Laura instead, or if they're at my house for some reason, I'm aunt or auntie to my little nieces and nephews. You have different names that only certain people can call you, but to them, that's your identity. That's how you're known. Maybe you had a childhood name. It drove me crazy when my grandpa would call me Lori. I wasn't a Lori. I never felt like a Lori, but he always insisted on calling me Lori, even though my name was Laura. It just didn't feel right because that wasn't my identity. I wasn't known as that. So I don't know if that happens to you. If you have different... I was Pickles on the basketball court. That was what my teammates called me. For two reasons. No. My last name was Clausen, and there's a brand of pickles called Clausen Pickles that you could buy at the store. It's spelled different, but it's the same. And the other was just for my defense. I love to pick off a pass or whatever. So that was my nickname on the basketball court. So you have just different ways that you're known. The trig is the same. There are different, we identify or we give the different trig values an identity. So a couple things you need to know before we get started. Sine and cosine of x, in terms of identities, they have no other identity. Okay, they are themselves. There's no other name by which they go by. Okay, they are the main identity, I guess, what you want to, I don't know what best way, main identities. Okay, they have nothing else for which that they would ever be known by. They are sine and cosine. We have already learned a couple. We have learned that tan can go by something else. Tan can go by sine over cosine. Those two things are equal. Okay, they are replaceable for each other. We've also learned that cotangent is replaceable. And what is cotangent equivalent to? Cosine over sine. That is actually called an identity because they are equal in every way. They are replaceable. They are identical to each other. Therefore, they are an identity. Finally, we've also already learned that cosecant and secant have other identities, okay, like a secret identity. Cosecant has a defined identity as what reciprocal? Who is cosecant most closely related to? Sine, by virtue of them being reciprocals of each other. So it's 1 over sine. That's how you write reciprocal, the reciprocal of sine, so we write 1 over sine. So then how would we write secant? 1 over cosine. So these are 6 you already know. I just need to show you how to use them in an identical way, in an identity process. So we're going to use those in problems. Think of yourself like a coach. All right, if you're a coach on the sidelines, say, of a volleyball game, and your setter is just not having a good day. All right, you need to sub for that setter. You need that setter to come out. But what do you need to replace that setter position with? Another setter. All right, because if you don't replace the setter with another setter and you have no setter out there, then your team can't do what they need to do they can't execute. Or maybe, using the volleyball illustration again, maybe you're in your rotation and you get to somebody who's not a very strong server. So the coach will make a strategic substitution at that point, and they'll take that person out and substitute someone else in because their strength is serving. And so they're in maybe they're really good at back row, and so they'll play the back row for a while. Same thing with football. Okay, if you take out your running back, they get injured or whatever, you got to replace them with another running back because your offense can't function effectively if they don't have the right players in the right positions. So you have to make substitutions in trig that are equal. Here's how it's going to go. Your job is going to be to start with an equation and to act as the coach and say, you're in, you're out, you're in. Here's the problem. Simplify the following problem. Cosine of x times tangent of x. All right, so that's the math problem we're dealing with. As the coach, you look at that and you're like, somebody needs to go out of this problem. I need to take somebody out and I need to replace them with something else. Now, cosine would never leave. Neither would sine. Sine and cosine are the two that you would always leave in a problem. So therefore, I only have one other thing I can take out. So I'm going to take out what? Tan. And I'm going to substitute in for tan its identity, what's equal to it, what can play the same position. And so what will I substitute in? Okay, so to show that I'm equal, I have to use an equal sign. And I say I'm keeping cosine, but I am swapping out tangent for sine over cosine. And when you do that, when you've swapped in sine over cosine instead of tangent, you notice that the cosine you left behind, or that you left originally, that now there's a cosine in the denominator next to it. And what can you do with those two cosines? Okay, you can reduce them, because one's in the numerator and one is in the denominator. And then, to show that it's still equal, you're left with sine of x as the only thing left, which you never replace anything for sine of x. So the final answer, as far as you could go, is sine of x. Done. It's simplified. The play is complete. We've run our offense. We're finished. Okay, it's a simplification. So the whole idea of our lesson today is replace and reduce. So you're going to look at a problem, decide what you're going to keep and what you're going to trade, and after you've done that, it should reduce to something that was more simple than what it started out as. Replace and reduce. So let's try another one. All right, simplify. The question is secant x divided by cosecant x. Now, I'm not going to keep either of these. Okay, neither of these am I going to keep, because neither of them are those main identities of sine and cosine. So my first job is to replace. So as the coach, I go, secant, you're out. Who's in? Instead of secant, who would I replace in instead of that? Okay, 1 over cosine. Division. Okay, same thing. I look at cosecant, say, you're out. Who's in? 1 over sine. And then you're supposed to reduce. Okay, but you're going, there's nothing to cancel because it doesn't work out. Reducing only works if it's multiplication. Okay, reducing only works if it's multiplication. So, as the coach, you're going to say, division, you're out. Okay, what do you replace? What can you do that's still equivalent, that's still legal in math? Division is the same as multiplication by the reciprocal. All right, so you say, I'm going to keep 1 over cosine. That's a keeper. But division is not. So division, you're out. And multiplication, you're in. And then what I'm going to keep is the reciprocal, which is sine x over 1. Now I can reduce. Because now I have ones, that one is in the numerator and one is in the denominator, and those reduce. And I am left with sine of x over cosine of x. Okay, I'm left with one numerator of sine of x and one denominator of cosine of x. Is there any way to simplify that further? What is sine of x divided by cosine x equivalent to? Tan x. And that is the simplest form because the one term is better than the other. So we are going to simplify that down to tan x. And that is the most simple it can go. It would be incomplete. Okay? Yeah. No, because when you multiply fractions, the top numbers get multiplied across and the bottom numbers get multiplied across. So sine of x times 1 is the top and cosine of x times 1 is the bottom. Yeah, we're not cross multiplying. There's no equal sign in between them. Okay, this is multiplication. All right. Now don't tune me out because you're like, oh, good, I get this. Okay, I need to show you more complex examples as they go. All right, let's try this. simplify tan of x divided by secant of x. Okay, last time you saw me replace the fraction things, plus you saw me replace the division sign in the middle. When you have a problem that's like this, I'm going to always recommend that instead of the way the book writes it as tan x over secant x, is that you rewrite it as tan x divided by secant x. It will always work out, your work will be cleaner, it will be reduced more easily if it's written that way. Okay, so that's my best advice to you, is to change it first. All right, then you look at it and you say, what can I replace so that I can eventually reduce? Replace, reduce, replace, reduce. So what do you see that we could replace first? Anybody see anything? Tan, okay, what can I replace tan with? Okay, so let's replace tan with sine over cosine. I'm going to keep my division for now. And then secant, you're out. What's in? 1 over cosine. So I replaced. Am I ready to reduce? Because reducing has to be with what mathematical term between them? Has to be multiplication. So I need to do another change. I need to have sine of x over cosine of x. I need to replace, again, replace the division with multiplication and replace this with the reciprocal. So I'm still in replacing mode. I've done replacing of the bar with the division sign. I replaced tan with sine over cosine. I replaced secant with 1 over cosine. Then I replaced the division bar itself with multiplication. Now I'm ready to reduce. So you just keep replacing, replacing, replacing until you're to the point where you can reduce. What reduces? Cosine. What am I left with? Sine of x over 1, it's redundant to write over 1. You do not need to write that, so sine of x is the most simple form. Okay, any questions on what we've done so far? Okay, so the next theme. So I've given you some things to replace. Let me give you a few more things to replace. Okay, this next set of replacements are called the reflection identities. How do you know when something is reflected? There's a negative somewhere in it. Okay, we've learned about reflections all year, so these are called the reflection identities. All right, if you have a negative inside, a negative inside, a negative inside, and a negative inside. And I know I've skipped something, and I skipped them on purpose. Okay, you can never leave a negative on the inside, so you need to replace. Okay, negatives on the outside are fine. But in this kind of trig stuff that we do, negatives on the inside are not okay. And so you're going to replace them. What you replace the negative on the inside with in all of these is a negative on the outside. Those are equal and replaceable. So for all of these, you can replace a negative on the inside with a negative on the outside. That has to do with the way their graphs are designed. The reason this is true is because all of these graphs are what we call odd symmetric. And so that's why we can do that. So which two have I left off? Cosine and secant. All right, in those situations, cosine of negative x and secant of negative x, those are the only two that behave differently. And if you see a negative on either of those, you can replace it with a positive everything. There's no negative at all. The reason for that is these graphs are what we call even symmetric graphs. They fold along the y-axis with perfect symmetry. Whoops, I wrote it wrong, sorry. No negatives at all. Those are the only two that behave that way. So if you see a negative in either secant or cosine, you can replace it with perfect positive numbers, and it has to do with the way the graphs were designed. You cannot do that with the other 4. The other 4 require the negative to be moved to the outside. So the way that'll work is in a problem like this. Simplify. I think your whole homework is this. Okay? Simplify the following problem. Cosecant of negative x divided by cotangent of positive x. So you need to look at that, and in your coach's mentality, you say negative, you're out. Literally, you're out in front. Okay, the negative, you're out. So negative cosecant x. You are replacing the negative. Make sure you put an equal sign in the front of your step to show that those two things are equal. And that was your first job. You look for a negative, and you say negative, you're out of there. If it was from a cosecant or a secant, it's out of there completely, and it's just gone from the problem, and it's just a positive value. But if not, it just goes out to the front. Then you're ready to do more replacing, and it's the same replacing we were just doing. So we will replace the next part. The negative is now sitting out in front, and what will we replace cosecant with? 1 over sine. Not division yet. What will we replace cotangent with? What was cotangent again? Cosine over sine. So first I replaced the negative. Negative, you're out of here. Next is cosecant, you're out of here, and cotangent, you're out of here. I'm replacing you. What's the next thing we say see ya later to? The division. So negative 1 over sine of x is fine. I'm going to replace the division with multiplication. And then I replace the second fraction with its reciprocal. Why do I do that? Why is multiplication necessary? Well, you can't reduce without multiplication. Okay? You have to get to the point where you have multiplication so that you can reduce. Do you see something to reduce? Okay? And I'm now left with a negative in front of what's left. Not cosine x. What is still left? Be careful. It's important that it's there. 1 over cosine of x. That's important. Okay? Now, the one on the bottom, ones on the denominator are redundant. We don't need those. But ones on the top are important. And now I can do one final replacement. 1 over cosine, you're out of there. I can replace you with something simpler. And what is the more simple version of 1 over cosine? Secant. So the negative is still there, and negative secant is the simplest. Hey, you'll get down to like one thing. That's the simplest thing that I could be. I'm down at the end. So what I started with and what I ended up with. Okay, please hear me. These are all equal. They are all equivalent. Okay, when you are a coach and you're replacing, still your team is out there. It's still the Valley Christian team on the floor. It's different people, but they are still all one team. They're equal. Yeah?
So you wouldn't be able to change the negative secant to a normal secant?
No, because it's not inside. Only if it's inside. Okay? All right, one more theme. So that was the theme for reflections. Besides reflecting graphs, what else did we do to graphs? Translate, shift, okay? And that's the last theme for today. Those are the shift identities. There are lots of shift identities, but in RAM class, regular advanced math, you only have to be worried about the pi halves shifts. That's all that you're going to need. Pi halves minus x, cos of pi halves minus x, tan of pi halves minus x. Those are the only shifts you have to worry about that I'm going to require you to know. Okay, the pi halves. You'll also need to know cosecant pi halves minus x, secant pi halves minus x, and cotangent. When you see that particular shift, you say, you're out of there. I'm going to replace all of you with something simpler. So for sine, when you see the shift applied to a sine, you replace it with regular cosine. Sine as a shift replaces with cosine. What do you think you do when you see cosine as a shift? Yep, replace it with sine. What do you think when you see tangent as a shift? No, even simpler than that. Cotangent. All right, what do you think when you see cosecant as a shift? Secant. And when you see secant? Cosecant. And when you see cotangent? Tangent. Okay, that's it. Those are the shift all the shift identities you have to know. You don't have to worry about pi thirds, pi fourths, any of the other stuff. All you have to worry about are pi halves. Okay? What this means graphically too is that the graphs of these are all the same. The graph of a shifted sine is the same as a regular cosine. The graph of a shifted cosine is the same as a regular sine. They all have the same shift to it. All right, so the way that you will see this in a homework problem is you're going to have to just be on your toes and look for the shift identity. And you say, I spot you, you're out of there. So simplify a problem like this. Cotangent of pi halves minus x times the cosine of negative x. All right, there's your question. And you're just looking for things to replace. Just keep thinking, I need to replace and reduce, replace and reduce, replace and reduce. So you spot a shift, and you think, shift, you're not going to be there. I'm going to replace you. So you put an equal sign to show that you're replacing. What will you replace that particular shift with? What does cotangent replace into? Regular tangent. Okay? What other, not going to be there, not in mine. Okay, what other thing do we see? The negative. We say, negative, not going to be there. Okay? And in cosine in particular, what can we replace that with? Just positive cos x. Okay, that's one of the only two you can do that with. Okay, one more thing. All right, we look at that now. Okay, I don't think so. I don't think you're going to be there anymore. What can we replace? Replace tangent. What do we replace tangent with? Sine over cosine. And I have multiplication, which means since I have multiplication, I should be able to reduce. And I can reduce the bottom cosine with the top cosine, and I'm left with the simple form of sine of x. There's a way that you can check your answers. If you type the beginning of the problem, so grab your calculator a minute, make sure it's in radian mode, put the top of the problem into y1, and the bottom of the problem into y2. And this is how you can check your work and know that you're right. All right, so in y1, you would put in the beginning of the problem, which would be cotangent. How do we type in cotangent on our calculators? Do you remember? Not the inverse, but the reciprocal. 1 over tangent. And then pi halves minus x. Times cosine of negative x. So you put that equation in y1, and then you put what you think the simplified answer is, which was just plain sine x, in y2. Okay. Under zoom, there's a special zoom for trig things. If you hit zoom, you'll see the bottom option is called zoom trig. That's a nice thing to use for graphs. You can go down to number 7. Okay. Whoops, I'm in the wrong mode. Hang on, I gotta wait for it to finish. See, I do it too. I make those mistakes. Nope, it's no, it's not right. Hang on. Okay, now I can fix it. I made a mistake that I tell you guys not to make. I didn't put my 1 over tangent in parentheses like I was supposed to. So I'm going to insert a parentheses. And then I get to the end of my tangent, and I need another parentheses. All right, then. Oh, still not doing it right. It's not beautiful. It's bad. Yes, it's supposed to look like that. Oh, where did it go? I didn't. My other parentheses didn't go there. Okay, now I've got my 2 parentheses in. There we go. You shouldn't see more than one graph. You should see the same thing. They are supposed to look the same as each other. Okay, and so that's how you check. You type your Y1 and your Y2, and there should be nothing contradicting each other. They should look exactly the same.